Okay, my friends, I know the anticipation of getting to the chapter on algebraic fractions has been killing you. We're finally here. So we're going to start off with something that we actually learned quite a while back. I think it was chapter 2 even, so clear back that far. So check out this first fraction. So there's just one fraction. It's not multiply, it's not divide, but let's remind you of how we reduce fractions or simplify fractions. So I got an 11 over 33. What do you normally do with an 11 over 33? You reduce it down. So 11 goes into the top one time, 11 goes in the bottom three times. So we even have calculators that would do that for us, 1/3. But you have variables. Variables have exponents. Do you recall the rule for exponents when doing division problems? If not, let me remind you, subtract. Now, I don't want to do 2 minus 3 for the x's because that gives me a negative. So we avoid negative exponents. So 3x's on the bottom, 2x's on top. If I subtract them, that leaves me 1x, and the bigger exponent was on the bottom. So recap, that's how we did those. So with the y's, I got 6y's on top. I got 3y's on the bottom. If I subtract them, I'm left with 3y's, and I'm done. So recap, we did that earlier this year. Now what we didn't do this year was a fraction that had a binomial or trinomials or worse. So over here on number 2, so we've got that 2x minus 14, and we've got a trinomial on top. So do you guys recall doing this? Long division. And that would be one way to do that problem. And we also learned synthetic, and even though that bottom one has a 2 in front of there, so there is a way to manipulate it so we could get a number in this box and do synthetic. But we never touched the third way to handle division problems. And the third way, and I'm sure this is going to make you excited, finish the statement yet again. When in doubt, factor it out. So we have a fraction, we have a numerator, we have a denominator. We're going to factor both. Well, I'm going to start with the bottom just to remind you that the GCF is the one that we're supposed to try first all the time. And there's a GCF of 2 on that guy. If I take a 2 out, I'm left with an x minus 7. The top does not have a GCF. And when we didn't have a GCF, 9 out of 10 times, it was just the 2 parenthesis thing. So we did have the little parenthesis, big parenthesis thing as far as factoring goes, and we did have grouping in chapter 6, but it's typically this. Now, I have some good news for you. The point of factoring is going to be to have something cancel. So the only way I can have something cancel is if one of these parentheses on the top matches the one on the bottom. So if the bottom has an x minus 7, what do you think the odds are the top's going to have an x minus 7? So let's go back to the actual factoring process. There was a 7 on the end. Well, what times what is 7? 1 times 7. And if I'm going to get negative 7, this guy would have to be a plus. Now you can double check that, do the outside inside thing, but I'm going to tell you right now it does check out, and it does give you that negative 13 that's in the middle. So here's the point. Over here, these guys are called monomials. Monomials, I just get to go hacking. I start canceling stuff out and reduce it down until I can't reduce anything more. If you have binomials and trinomials, etc., you need to factor them first. And what I can do is I can cancel matching binomials. Now, those are exactly the same, and that's why I can cancel them. So what's left on top is a 2x plus 1. What's left on the bottom is a 2. Now, it'd be really tempting to cross off those 2's, but you can't. Here's why. The top is a binomial. The bottom is a monomial. I can only cancel binomials with matching binomials like we just did right there. So unless you literally have a 2x plus 1 on the bottom, no can do. And that guy's done. All right, notice though, this did not say times another fraction. This guy did not say divide another fraction, and that's what section 9.1 is. So we're going to have to ramp this up a notch. All right, check out these two problems, 3 and 4. Can you determine which one you get to cross multiply? That is something we're going to be doing later in this chapter. The one on the left with the equal sign is the one that you can cross multiply. Guys, we are not doing that yet. So do not even think about doing any cross multiplying for any of these problems. Well, number 4 is a times problem, and it still does involve something with the word cross. How about this? Do you remember that way back when they were first teaching about fractions? You can do a little thing called cross cancel. So here's what we mean. Here's a monomial of 5. It's a monomial of 10. I can cross-cancel those. So 5 goes into 5 one time, 5 goes into 10 two times. Do you recall doing that way back in the day? Now, careful. It would be really tempting to cancel that single x with that single x. But I'm putting parentheses around these to remind you that they are binomials, and you can only cancel binomials if they're exactly the same. And they're not. One's got a -2, one's got a +3. Can't cancel. Now, what I can do is take care of the times. And they supposedly taught you way back when, if you were going to multiply, you multiply across. So that's a distributive property on the top, which would give me that when I multiply times 2. And if I multiply that x plus 3 times 1, well, I'm obviously going to get x plus 3. Now, again, do not cancel the x's. You can only cancel a binomial with an exact matching binomial. And those two are not matching. So we are done. Okay, let's try a couple more examples here. Down at the bottom. So notice, no factoring involved. I don't see any pluses or minuses anywhere in this problem. So that's kind of the key to tell me, hey, try a GCF or try the two parenthesis thing. I don't have that. But what I can do is I can just cancel. Go ahead and zoom in a little bit more on these. There we go. Give myself a little bit more room. I like starting with the coefficients. What number goes into 4 and 10? 2 goes in there twice. 2 goes in there 5 times. Try to be neat about these. These can get messy. What number goes into 9 and 12? 3 does. 3 goes into 9 3 times. 3 goes into 12 4 times. Now, just because the A's are not right above one another, corner to corner, I can still do the same thing that we did on that first problem. I got 1A and I got 2 A's. Subtract the exponents, I'm left with 1. I got 5 B's. I got 3 B's. Subtract the exponents, I'm left with 2. And where was the bigger exponent on top? So once you have reduced everything that's possible, cross-canceling, cross-reducing, then I take over with the original problem, which said do multiply. So I'm going to multiply the top. I see it 2 times 4 on the top, which I can do. I also see times a b squared on top. I see a 3 times a 5 on the bottom, but I also see a times a on the bottom. Now, if you have correctly cross-canceled, you will not be able to reduce at the end, but it doesn't hurt to check. Can you reduce 8 over 15? You cannot. Therefore, that guy's done. All right, now on number 6 is a little extra first step here. So the PEMDAS thing. Well, where does the M occur in comparison to the E? So E's are supposed to be done first. So what we're saying here is this exponent right here has to be done first. So again, way back to chapter 2, I think it was. So what's happening here? I am taking and cubing a 5. Well, 5 cubed is 125. Feel free to use a calculator. The rule for exponents was to times them. I get x to the 3rd. I get y to the 12th. Hope you remember that rule. Well, now that exponent's taken care of, I can worry about that times. And if I'm doing multiply, we're talking about cross-canceling. 3 goes in there once. 3 goes in there 3 times. I have 1x down on the bottom, 3 x's on the top. I'm left with 2. I got 9 y's. I got 12 y's. That leaves me with 3. So if I were you, I wouldn't cross things off so bad that you can't see them anymore, because right, I can go back and double check now if I needed to. So I do not see anything else that I can cancel. So what do I have left? This doesn't hurt either. You could circle what's left. I get a 1 times that, times that, times that. Well, 1 times 125 is 125, times an x squared, times a y cubed. The only thing that I see left on the bottom is that 3. And again, wouldn't hurt to check to see if 125 over 3 reduces. But if you have correctly cross-canceled everything in the problem originally, it shouldn't reduce at the end. And 125 over 3 does not reduce. All right, folks, I'm going to cut it off here for part 1 video. Definitely check out part 2 because part 2 requires factoring, and that's a little bit different. Thanks for watching.